Hello all, welcome back. In this video, we are going to learn about parallelogram law of forces. So, by using this law, we can find the resultant of a body when two forces acting on that. So, first of all, we should know what is a resultant. Resultant is nothing but when two or more forces acting on a body, those multiple forces can be converted into single force, which gives the same effect of those multiple forces. Same effect means in magnitude and direction, the values should be the same. See, for an example, there is one body and multiple forces are applying on that means this all the forces can be converted into single force. This single force has to give same amount of magnitude and displacement as these three forces are combined. So this force has to give the same effect on this body as this three force combined. So this is what a resultant is about. And by using this law, we can find what is the resultant force value. So I'm going to apply this law to this body. Here two forces are acting on that. I'm going to take this body forces here for easy calculation. If this is F1 and this is F2, means the resultant would be this one. This is what defined in this law. You see that if two forces acting simultaneously on a body at a point, that is F1 and F2, are present in magnitude and direction by two adjacent sides of parallelogram. This is adjacent sides of parallelogram, and the resultant is represented in magnitude and direction by the diagonal of the parallelogram. This is the diagonal, so this is a resultant. This is what this law states. But we should find what is the R value, the resultant value. So we can rewrite this triangle as this. This is F2 value, this is the red one. The green one is F1. This F1 has two values. In a horizontal, it is F1 cos theta. In a vertical, it's F1 sin theta. See, in the consider this is an X and Y axis. If one force is acting on this plane means at some theta means it should have two components. The horizontal component is F cos theta and vertical component is F sin theta. This is horizontal, this is vertical. So that only I'm rewriting here. I can remove these things. That is for rewritten here. So this F1 has two components, F1 sin theta and F2 cos theta. This is horizontal components. See in the this is origin means this is opposite side. This is adjacent side. Adjacent side means F1 cos theta plus F2. This is adjacent side and this is hypotenuse. So as per Pythagoras theorem, this R is equal to and the hypotenuse squares is equal to sum of square of other two sides, which is F1 cos theta plus F2 square plus F1 sin theta. Square. So if we remove the square means the other side will go for root. Then if I expand this one, F1 cos square theta plus F2 plus 2 into F1 plus F2 cos theta plus F1 square sin square theta. Then these two terms have the common value of F1 square. That F1 square, if we take it out, the inside would be cos square theta plus sin square theta, and we have F2 term, F2 square, sorry, and another one is F1 plus F2 cos theta. F2 cos theta. So this value is equal to 1 as per trigonometric formula. F1 square plus F2 squared plus 2 into F1 F2 cos theta. This is the value for value. This is a formula to calculate the resultant value. So this is a formula to calculate the resultant value, and there are some case we can apply. The case one is if theta is equal to 0 degree means, which means the F1, see this is F2 and F1, that is also in the same axis. So the resultant value is would be sum of the resultant value would be, if you apply here this 0 value to this theta, cos theta value is equal to 1, then it will become like F1 square F2 square 2 F1 F2. Then it could be rewrite as F1 plus F2 the whole square inside the root. This root and square root get cancelled. R is equal to F1 plus F2. So R is equal to F1 plus F2. In the same way, you apply theta is equal to 180 degree means the cos theta would be -1. So the resultant value would be F1 minus F2. And if the theta value is 90 degree means, consider the third case, theta is equal to 90 degree means cos theta value cos 90 is equal to 0. This whole term would get cancelled. R is equal to root of F1 square plus F2 square. Is there any angle value other than this value means we can substitute here to find the resultant value. And another important thing in this formula means, in this law, we should find the angle of the resultant force. Let's consider it as alpha. What is the value of alpha? That is also important, because this resultant means we should have the magnitude value and the angle of action also we should find. This alpha, if considered tan alpha, what would be the tan value? Opposite divided by adjacent. So opposite side is F1 sin theta and adjacent side is F2 plus F1 cos theta. So alpha means tan inverse F1 sin theta and F2 plus F1 cos theta. So this is a value to find the angle of resultant force. And this is the value to find the magnitude of resultant force. So in this video we learned what is a resultant force and how to calculate the resultant force value, magnitude and angle by using parallelogram law of forces. Okay, thank you.